Hey buddies, what's up? Welcome to PhDians family. In this video, you will be able to upgrade your skills on how to cite and when to cite your data. This video is customized to early career researchers as this video will help them to build their reputation within their academic and scientific communities. Before I could start this video, let me highlight some of the important points. If you have not signed up for Elsevier Research Academy, then please do sign up for Elsevier Research Academy, where you can get benefited with different videos highlighting about research management, and how to crack fundings, and how to write a research manuscript, etc. And these videos are exclusively for a research community. By watching these videos, you will be benefited with different skills. Also, after completion of these modules, by watching these videos, you can also gain a certification from Elsevier Research Academy. So guys, what are you waiting for? Sign up and get benefited. It's a lifetime opportunity. I'll be providing the link in the description box. So apart from this, very important, please do like, share and subscribe to your favorite channel, PhDians. So this video is brought to you by Elsevier Research Academy, and the presenter is Dr. Tim Clark. He is a professor and pioneer in data citation and implementation. His major research findings can be cited in biomedical informatics. So without wasting much of time, let us jump on to the video. So I hope you will like it. Please do share and subscribe. Please do watch the video till the end, because every step is important so that you can get benefited. So let's straight away watch the video.
This is going to be a short talk about what is an emerging practice and a very important practice for reproducibility and reuse of scientific findings, particularly, I would say, in biomedicine. I'm going to walk you through sort of the foundations of this practice in theory, what we're doing about it in practice, and how it actually benefits both science as a whole and you. So, NIH, the National Academy of Sciences in the U.S., and other science policymakers, not just in the U.S., but for example, the Royal Society in Great Britain, and comparable institutions in the Netherlands and so forth, have been very concerned over the recent period about scientific reproducibility and robustness of results. You may have heard these reflected in discussions about false positives in the literature, increasing rates of article retractions, big data and data reuse, and so forth. And a number of significant science policy studies over the past, say, 5 years or so have recommended that primary data that forms the foundation of any published scientific findings be archived in a robust way and cited directly in the article. NIH is now running something called their Big Data to Knowledge program, or BD2K. And the goal of Big Data to Knowledge explicitly is to facilitate broad use of biomedical digital assets, that they should be discoverable, accessible, and citable. Another way of saying this, by the way, and this was started by this whole discussion of these principles was actually started by people in the Netherlands, the acronym FAIR, findable, accessible, interoperable, reusable, applied to data sets. So there are technologies and many recommendations now in place about doing this, and there's even a significant NIH-funded program to construct kind of a PubMed for data. But in order to discover data and reuse it, you need to be able to find it. And to find it, it has to be there in the first place. It can't just be on your thumb drive or in your laboratory website. It has to be someplace that's somewhat persistent and reliable to access. In the same way that publishers like Elsevier and Nature and so forth make their publications available on websites that persist over time. So why should we archive and cite data? Well, these are the kind of big picture reasons. One is for better science. We want to promote transparency and validation. If you publish a finding and you say, here's a graph that I've generated off my data set and it supports this interpretation and this finding, that's all well and good, but it would be very nice to know, see the primary data that you actually used to generate that graph, and to, in fact, to know in clear detail the algorithms that you used. That's always been part of the scientific method, but with the growth and size of data sets, they can no longer fit in little tables in the publication. So another reason to do it is for reuse and discovery. Aggregating data sets, putting them together for big data meta-analysis, and to extract new knowledge. In our work here at the Massachusetts General Hospital, we were involved in a major program of finding new targets, therapeutic targets for Alzheimer's disease, and we use open data sets extensively in this. The last reason, big picture reason, is to radically improve biomedical translation. You have to have reproducibility and robustness of findings in order to translate them over to industrial drug development. And ultimately, that's how we develop therapeutic agents to cure diseases. So let me give you some more reasons to cite data that are more focused on you. The first one is it's just plain good scientific practice. Data has been foundational as a criterion of truth in science since the scientific revolution, when we changed over from just having arguments and discussions about conclusions from the ancient classical literature to actually finding and developing findings on the basis of data sets. You want to be good at your job, right? So you should do it. Another question that comes up is, and you could call this the future you versus the present you. In the future, you're going to want to reuse your own data, and archiving it in central repositories is a great way to back it up and make sure it's accessible. Making it accessible, citing it and making it accessible to others also makes it accessible to you in the future. We've built data archives here in the Harvard community at the Stem Cell Institute, and when we first started this practice, people asked us why they should put their data sets in there, and we give them arguments to convince them that it was a good idea. And they sort of said, oh, okay, we'll do that. And then about a year after we built this archive, people started coming to us and saying, oh, you know that data set that I put in there, is there any way I could get that? Because my postdoc had that data, and now he's gone. So future you versus present you. Want to provide for future you. And the last reason, and this is very important, is funders spend a lot of money to enable you to get that data, and now they're thinking of it as a resource that they don't want to lose, they don't want it to go away. So NIH and other funders will require it. So how did we get into this business of data citation from these studies going into practice? And there was an intermediate step called the Joint Declaration. And this was a meeting or a series of meetings hosted by our nonprofit organization Force 11 and brought together people from the National Academy of Sciences, European agencies, and so forth, to work through, to kind of harmonize the recommendations of all these studies and boil them down to a few principles. And you can see them here. And without going into them in depth, I'll just say the number one thing is that data are legitimate citable projects of research. They are the foundational evidence in science, so you have to cite data where an assertion relies upon it. And then there are technical aspects about unique identification, access, persistence, and so forth that are important to support point 6, which is facilitating access to and verification of data. And the last of these, interoperability and flexibility to accommodate different communities. Now, let's go into citing data versus citing literature, because I think some people can get a little confused. I've heard the question, well, if I cite data, then I'm not citing literature. So if I'm citing my data sets, I'm not citing my papers, and that's going to reduce my impact factor and so forth. Actually, it doesn't work like that. So there are sort of 3 use cases or situations that we're going to talk about. First is you should archive and cite your own primary data sets when it's primary data on which you base claims in your article. It's similar to the idea that's very common, especially in, say, molecular biology papers, where you have an image or a chart and you make a statement and you say, see figure 3A. When, for example, figure 3A is your image data or stats plot. Only in this case, you're pointing to an external reference, right? So cite your data when you base a finding on it, and it's your data, right? It's your primary data. When should you cite someone else's data versus citing their literature? You cite someone else's previously archived data sets when you use them as data inputs to your computational analysis. So you're doing a meta-analysis, you're reanalyzing data sets from Sage Synapse or Geo or some other data repository. Only when you use them as actual data input to your analysis. Right? And lastly, the sort of long-standing existing practice of citing existing literature remains as it does, and it is still very important. You cite the existing literature as you normally do when you're citing someone else's claim, finding, or assertion. Right? And I'm going to talk about another step. After the development of these principles, a lot of discussion went on about how do we move from having these things as abstract principles that lots of people agreed on. In fact, over 100 scholarly organizations endorsed them, including many publishers and funders, to something that could actually be applied in practice. And this is where the Data Citation Implementation Pilot came in. It was organized through the Force 11 Consortium and was funded as part of NIH's Data Discovery Index project. And the goals of this pilot really were to get the early adopters together, essentially, and to make sure that they agreed as community participants in exactly what the implementations, the technical implementation details would be and how they would affect their say, publishing workflows, author instructions, the metadata on the repository landing pages, and so forth. Right? And Elsevier has played an important part in this and is continuing to do so. I must say, Helena, Cousijn, co-chairs our publisher early adopter group in this pilot. We have a lot of participants actually, though, and that's really important. We're trying to make sure that the early adopters get on the same page and that technically everybody's taking the same approach so that software agents and people have a consistent experience across the network. So all of these logos, and this is what I call the mandatory logo fest in many talks, right? All of these groups and many others have joined this pilot and participated and contributed to it. And we hope to have additional work going beyond this in the future and extending it to many more publishers. But I think we have really quite a few of the major ones here. Now, what does a data citation look like? Well, it's not so peculiar, actually. It's really very similar to a literature citation. It consists, and this little diagram maps some of the characteristics of a data citation to the principles that we discussed earlier. So you have the authors, you have the year, the data set title. Instead of a journal name, you have the name of the repository or archive in which it's deposited. Could be GEO, could be European Nucleotide Archive, could be Dryad, could be Zenodo, could be a number of these repositories. You have then also a global persistent identifier. What does that really boil down to? It boils down to a DOI or a URL. And actually, in fact, it boils down to a URL because DOIs, which you're probably quite familiar with, only really resolve when they have the proper prefix, like http://doi.org/ and then the DOI. Then it becomes a URL that you can resolve on the web. So this is very recognizable, and the only really different things here is that we have at the very tail end we have, well, first of all, the persistent identifier is required, and the version or subset, because it's data set, is also required. So what does this look like at a sort of top level? So on the left, we have the document citing the data. So you have a citation that ties the assertion in the paper to a reference in the reference list. And there's, as I said before, there's a persistent unique identifier that takes you to a landing page in the repository. The landing page describes the data and then allows you to get the data. So it's actually very straightforward. So the components of all of this are really, to make it happen, are the publishers, the repositories, you, the authors, and the informaticians. And we're hoping to bring all of these together, and I think we're doing it. In this project, we had an international executive from many different institutions. And as I mentioned, we had a publishers expert group headed by data-related people or data management people from Elsevier and Springer Nature. They've done a tremendous job. So we have a publisher's roadmap that's really going to be published in the peer-reviewed literature early next year. As Elizabeth said, Elsevier announced that they've implemented the specifications that they helped co-develop with many others through our initiative in 1,800 journals. I believe from discussions that I've had that Springer Nature and other publishers are not terribly far behind. So you'll see this start to be widely implemented. So this is just a little discussion of what the publisher's roadmap approach is. I'm sort of running behind, so I'm going to skip ahead. We also had an expert group put together from data repository experts to kind of coalesce how you would see data sets represented on the landing page of a repository and what machine readable metadata would be available to software agents, and et cetera. Drill way down to the sort of geek level here, but it's very important. And it's a little snap that we took at San Diego at our last workshop. and their roadmap is near complete as well. So the key thing here about landing page metadata is that it makes the data set information available to software to construct these data discovery indexes, which are, as I mentioned, like PubMed for data. So lastly, I guess I want to say that we need to systematically cite, archive, and cite data to improve the scientific transparency, reproducibility, and robustness of the literature. The literature is our lifeblood, but there are a lot of problems in the literature, and we now have both the incentive and the means to fix them. So persistent discoverable archives will enhance our capability to validate and reuse data. And the goal here, at least in the biomedical realm, and I think this actually applies to other realms as well, is to significantly improve the ability to translate research findings into either new findings in other areas, and continued advancement of the science, or translation into practices that benefit the broad population.